To a review of topic 3.8, the tangent function of unit 3. This one says that the portion of the graph of the function f is given over here, where f is the result of multiplicative transformation of tan x. So what is the period of the function? Okay, even it doesn't really matter what kind of transformation happens. For us to find the period, all we are looking for is after how much, what interval of x is the curve repeating itself, and it looks like this is a portion of curve which is getting replicated, and we can clearly see that this portion is between negative pi, and between negative pi and pi, what is the total length? Obviously, that's 2 pi. So the period is just 2 pi. Uh, in all these questions, we need to find what is the period of the function. So remember in sinusoidal curve in the videos when we were doing, I told you that the period is, for example, I said that a sine b bx minus c, or x plus c, doesn't matter, plus d, or a cos bx plus c plus d. I said that the period is 2 pi over b. Absolute value b to be precise, because period is positive. But for tan and cot, in fact, let's say I have a tan bx plus c plus d, or a cot bx plus c plus d. The only difference is that 2 pi is now pi. So the period is pi over absolute value of p. So I think this basically answers all the questions. Just have to plug in the numbers. So pi over b is the coefficient of x, which is 4. That's the period. This will be pi over 1/3 is the coefficient of theta, which is 3 pi. This will be pi over coefficient of theta is pi, so that's 1. And this will be pi over coefficient of theta is pi over 4, which is pi over 4 is pi times 4 over pi, which is just 4. So that is the period of this question. Okay, now we are talking about vertical asymptote. So there's a way we can generalize this scenario, because see, I hope you know the curve of tan x, right? For example, let me elaborate this over here. Y equal to 10x. This figure, the graph rather, I'm just drawing one period, looks something like this, right? And this is pi over 2 and this is negative pi over 2, which are asymptotes. So don't you think the asymptote, and if I were to draw another cycle of this, it will be like this, and this will be 3 pi over 2. If I will draw something like this will be negative 3 pi over 2. So my point is, whenever x is an odd multiple of pi over 2, it has an asymptote, right? These vertical dotted lines are asymptote. So all we have to do is set the inside thing of the tan to the odd multiple of pi over 2. I'm saying inside thing, right? Inside thing. Whatever the inside thing is. Let's say I go back to this. Let's say the inside thing is this. So you will set this entire thing to odd multiple of pi over 2. And how do you write odd multiple of pi over 2? You will say 2k plus 1 pi over 2. This will always be odd, where k is any integer. Because it doesn't matter what k you put. This 2k will always be even, and this even when added with 1 will always give you an odd number. And this is in fact a way we write odd number. Any odd generalized odd number is written as 2k plus 1, and any generalized even number is written as 2k. Okay, so this is all the theory. All we have to do now is set the inside thing to 2k plus 1 pi over 2. And the value of theta will just be divide both sides with 2. So the answer will be 2k plus 1 pi over 4. Let's distribute this 2k inside. So it will be 2k times pi over 4 plus pi over 4. 2 2s are 4. So it will be k pi over 2 plus pi over 4. So pi over 4 is here and k pi over 2 is here. So it has to be option C. That's the correct choice. Likewise over here, in vertical asymptote, 1 over 4 theta should be equal to 2k plus 1 pi over 2. Multiplying both sides with 4, I have 4 times 2k plus 1 times pi over 2. 2 times 2 is 4. So I have theta is equal to 2 pi times 2k plus 1. I'm just going to continue here. And if I distribute, it will be 4k pi plus 2 pi. And 4k pi plus 2 pi is definitely option C over here. Similar question. So the inside thing is to be equated with 2k plus 1 pi over 2. Pi and pi is gone. So theta is 2k plus 1 over 2. Or if you want to write it as times 1 over 2, that's one and the same thing. But it just helps us to realize that, okay, eventually this 2k will be multiplied to 1 over 2. So 2k times, or if you want to understand it like this, I can write 1 over 2 in the front, and now you can distribute the 1 over 2. So that 1 over 2 times 2k is just k, and 1 over 2 times 1 is 1 over 2. So it is k plus 1 over 2, which is option C. Everything is C. Okay, that's this one. A theta minus pi over 2 will be 2k plus 1 pi over 2. So theta minus pi over 2 is equal to, let's distribute this. So 2k times pi over 2 is k pi, and 1 plus pi over 2, 1 times pi over 2 is pi over 2. Adding pi over 2 both the sides, so k pi plus pi over 2, and then plus pi over 2. So pi over 2 and pi over 2 are added. So this will become k pi plus pi, which is option interesting. None of the option. But can I take pi as a common factor? So it will become k plus 1. And don't you think, guys, k plus 1 is just another integer? So can't I just say that theta is some another integer n times pi, which is obviously matching with this format. The only difference is they have used k for integer. I have used n for integer, but this is the correct choice. Right, graphical transformation. So we are given a graph and they're asking that if the equation of this graph is a tan bx, then compare a and b. Remember, they're not really asking about the actual values. It doesn't really matter. We can just analyze from our knowledge of transformation. For example, a regular tan x curve looks like this, right? Just a one wave of it looks like this. And if I put a negative sign, let's say a becomes negative, so that becomes a reflection about the x-axis. So if you reflect this about the x-axis, definitely it will look like this, right? It will look something like this. So this is how this curve is also looking. So yes, a should be negative. It makes sense. So a should be less than 0. And don't you think that these values, this is pi over 2 and minus pi over 2, and now this is pi over 4 and minus pi over 4. It means that this is a horizontal shrink. And whenever we have a horizontal shrink, it means that the B has definitely been changed. Remember that B works the other way around. For example, if there's a horizontal shrink, then B will be greater than 1. This will result in a shrink, which is happening in our case. And if B is less than 1 and greater than 0, this will become a stretch. So horizontal dilation and horizontal translation works counterintuitive. It means that since we are experiencing a shrink over here, it has to be B greater than 1, which is option C. On similar grounds, we have this question. So right off the bat, I can say that A has to be positive because there is no reflection of any sort. This is just matching the nature of its parent function, which is tan x, which looks like this, like I just said. Okay, what about the B? So here you can see that these values are now stretched. It was pi over 2 minus pi over 2 in the parent function, and now it's pi into pi and negative pi, which means there is a stretch, and a stretch means B is less than 1. It works counterintuitive. So A is positive and B is less than 1. Okay. Here we have a different scenario. We need to find C as well. So let's work on B first, and they are not just asking the sign, they're asking the values. I think B we can easily find using the period, because the period of this is, as you can see, it's going from negative 2 pi to 0. So pi over B, pi over B is going to be, although it should be absolute value of B, but then once again, all the values of B are positive, so we are just going to resort on the positive number. So pi over B should be 2 pi, right? The period is 2, sorry, what am I saying? The B value will be pi over period. That was also correct, but I'm just rewriting it so that we can directly get B. So pi over 2 pi is B, so B is just 1 over 2. So it has to be option A or B. And what does it look like? I mean, obviously a very easy way to find the value of C is to test any point. So I have the value of B, which is this. Okay, now pi comma 0, let's test. In fact, you know what? Actually, it would make sense to test the asymptote here, because this should obviously turn into an asymptote at 2 pi, right? So 1 over 2 x plus c, um, or actually rather than asymptote, because that would actually involve reverse engineering the option. So let's just take any point. In fact, let's just take probably this point, pi comma 0. So it means that y is 0 and x is pi. And when is tan 0? Tan is 0 when this thing is also 0, because tan of 0 is 0. So which means that pi plus c is 0, which means that c is equal to negative pi. So negative pi is over here. So the answer is option B. I think there's a similar question. We can first figure out the value of B, because we know the period right away. It's from negative pi over 2 to pi over 2, which makes, sorry, negative pi over 4 to pi over 4, which makes pi over 2 as the period. So the value of B will be pi over period, and the period is going to be from negative pi over 2 to, we just said is pi over 2. So pi and pi is gone, and 1 over 2 is just 2. So this is the value of B, and we are so lucky that there is only one option where the value of B is 2, right? So that's the only correct choice. Okay, here we are given a theta in standard position. The slope of the terminal ray is -1, which means that tan of theta is, okay, I'll talk about that in a minute. Which of the following could be the measure of the angle? Um, I'm not sure if you know this already, but the slope of of an angle in a standard position is nothing but the tan theta. Right, I can prove this. Let's say we have, let's take any straight line, maybe straight line, something like that. And let's say it is making an angle of theta with the, in the standard position. Okay, let me make a triangle over here. Let me make the triangle with a different color. So let's take this as a triangle. Okay. What is slope? Slope is rise over run, right? So rise is this, which is change of y, and run is this, which is change of x. And slope is rise over run. And don't you think, guys, this is nothing but the property of tan, because tan is opposite over adjacent, right? So all we have to do is figure out that at which angle the tan is -1, because they are asking that tan of theta is -1, right? Okay, for this you need to know the value, know the earlier as well in one of my videos, I think 3 point maybe 1 or 2, something like that. I talked about all students take calculus, which is very important. All students take calculus. Uh, Here A means all trigonometric functions in quadrant 1 are positive. S means only sine and cosec. T is tangent and cotangent, and C is cosecant and secant are positive. Now, they are saying that tan of theta is -1, which means that obviously it has to be either in quadrant 1 or quadrant 4, because in quadrant 3 tan is positive, in quadrant 1 all are positive. And the reference is -1 because, you know, that's the reference, because the for reference we just ignore the angle. So tan pi over 4 is 1, and something that is also if you look at 3 pi over 4, that's actually an answer, because tan of pi over 4 is 1 and tan of 3 pi over 4 is -1, because that's in quadrant 2 and the pi over 4 is the reference. Likewise, the slope is undefined. So which of the following tan of theta is undefined? It has to be 3 pi over 2, because we already discussed that odd multiples of pi over 2 are asymptotes, vertical asymptotes, so undefined. Here we have to figure out that when is tan theta √3. So I think let me give you the standard values you should be aware of. You should know that tan of 0 is 0. You should know that tan of pi over 6 is 1 over √3. You should know that tan of pi over 4 is 1 over √2. You should know that tan of pi over 3 is √3. And tan of pi over 2, anyway, I think you know by now, because that's the odd multiple of pi over 2. So that's undefined or does not exist. All right. So you're looking for √3. So if you, I'm sorry, I have written an entirely incorrect value. Tan of pi over 4 is 1. I was thinking about sine for some reason. Okay, so √3 is definitely pi over 3, right? So pi over 3 is nowhere. That's interesting. It cannot be pi over 6. And it is also positive, right? So pi over 3, reference angle of pi over 3 in quadrant 3 will also give 1, because in quadrant 3 as well it is positive. So the reference angle of pi over 3, having pi over 3, and that is in quadrant 3, is 4 pi over 3. That's the answer. And here the slope of the terminal is tan theta is 0. So tan theta is 0 when theta is either 0 or pi or 2 pi, 3 pi, 4 pi, anything like that. So that's when the tan is 0. So the answer has to be option C in this case. Right. Here, oh, that's the similar question. Oh, that's the other way around. In fact, that's pretty easy, because they are asking what is tan of pi over 6 basically, which is just 1 over √3, right? We just talked about this in the last slide. And here they're asking tan of 5 pi over 4. To know tan of 5 pi over 4, you should know what is tan of pi over 4, because that's the reference angle if we just ignore 5. And tan of pi over 4 is 1. And tan of 5 pi over 4 is in quadrant 3. In quadrant 3 also, tan is positive. So the answer is 1 again. So D. And lastly, these are all the values which are once again dependent on just the way we were doing. So we will just find the reference angle here by ignoring this 7. So tan of pi over 6 is 1 over √3. Then we will ask 7 pi over 6 which quadrant this guy is. This guy is in quadrant 3, and in quadrant 3 tan is positive. So that's my answer. Here I will find the reference angle by ignoring this 3. So I will ask 10 pi over 4. 10 pi over 4 is 1. And 3 pi over 4 is in quadrant 2, and quadrant 2 tan is negative. Likewise, we ignore this. Tan of pi over 3 is √3, and 2 pi over 3 is in quadrant 2. Quadrant 2 tan is negative, so negative √3. Here, tan of pi over 3 again. √3, this is in quadrant 4, negative. 11 gone, pi over 6 is 1 over √3. 11 pi over 6 is in quadrant 4, negative. Tan 2 pi, we just discussed that tan 0 pi, 2 pi, 3 pi, 4 pi, minus 2 pi, all are 0. Tan of negative pi over 2, we just discussed that odd multiples of pi over 2 are undefined or does not exist. Here we ignore this. Tan pi over 4 is 1. 5 pi over 4 is in quadrant 3, so positive. Here we ignore 7. This will become pi over 3, which is √3. But what is 7 pi over 3? That's interesting, because this is in quadrant 1 again. Because 7 pi is like, you know, you can convert this into degrees by replacing pi with 180. So 7 6 are 42, 420, which means that you make one complete turn by 360 degree, and then you go 60 degree further, which is like 360 and then 60. So quadrant 1, and in quadrant 1 obviously tan is